Hello everyone! In this video, I will discuss some concepts on organic chemistry. Consider for a moment activities that occupied your past 24 hours. You likely showered with soap, drank a caffeinated beverage, and ate a few meals, read a newspaper, listened to a CD, and traveled in a vehicle that had rubber tires and was powered by fossil fuels. If you did any of these, your life was touched by organic chemistry. What is organic chemistry? Organic chemistry is the study of compounds that contain the element carbon. While it may seem odd that an entire discipline is devoted to the study of a single element in the periodic table, millions of organic compounds are known. These organic chemicals affect virtually every facet of our lives. And for this reason, it is important and useful to know something about them. Clothes, foods, medicine, gasoline, refrigerants, and soaps are composed almost solely of organic compounds. Some like cotton, wool, or silk are naturally occurring. That is, they can be isolated directly from natural resources. Others such as nylon and polyesters are synthetic, meaning they are produced by chemists in the laboratory. By studying the principles and concepts of organic chemistry, you can learn more about compounds such as these and how they affect the world around you. Now, let us talk about the common features of organic compounds. First, all organic compounds contain carbon atoms and most contain hydrogen atoms. Carbon always forms four covalent bonds and hydrogen forms one covalent bond. Carbon is located in group 4A of the periodic table. So, a carbon atom has 4 valence electrons. Since hydrogen has a single valence electron, methane, which is CH4, consists of 4 single bonds, each formed from 1 electron from a hydrogen atom and 1 electron from carbon. Next, carbon forms single, double, and triple bonds to other carbon atoms. So when a compound contains 2 or more carbon atoms, the type of bonding is determined by the number of atoms around carbon. Consider the 3 compounds drawn here. So on the leftmost part, which is the ethane, a carbon atom surrounded by 4 atoms forms 4 single bonds. In ethane, which is C2H6, each carbon atom is bonded to 3 hydrogen atoms and 1 carbon atom. All bonds are single bonds. So on the middle part, which is the ethylene, a carbon atom is surrounded by 3 atoms forms 1 double bond. In ethylene, which is C2H4, each carbon atom is surrounded by 3 atoms, which are 2 hydrogens and 1 carbon. Thus, each carbon forms a single bond to each hydrogen atom and a double bond to the carbon atom. And on the rightmost part, which is the acetylene, a carbon atom surrounded by 2 atoms generally forms 1 triple bond. So in acetylene, which is C2H2, each carbon atom is surrounded by two atoms. So, one hydrogen and one carbon. Thus, each carbon forms a single bond to hydrogen and a triple bond to the carbon. Next, some compounds have chains of atoms and some compounds have rings. For example, three carbon atoms can bond in a row to form propane or form a ring called cyclopropane. Propane is the fuel burned in gas grills and cyclopropane is an anesthetic. Next. So, organic compounds may also contain elements other than carbon and hydrogen. So, any atom that is not carbon or hydrogen is called heteroatoms. So, the most common heteroatoms are nitrogen, oxygen, and the halogens, which include fluorine, chlorine, bromine, and iodine. So, organic compounds may be written in different forms. So, it can be written in molecular formula. It can also be in condensed structural formula. It can also be expanded structural formula. And it can also be skeletal formula or line angle formula. First, let us have the molecular. So, when we say molecular, the total number of carbon and hydrogen atoms are given, but not their arrangement in the molecule. For example, let us have heptane, which has a molecular formula C7H16, meaning to say there are 7 carbon atoms and there are 16 hydrogen atoms in heptane. So that is what we call the molecular formula. So the total number of carbon and hydrogen atoms are given. Next is the expanded. So expanded structural formula shows how the hydrogen atoms are arranged around a carbon atom. For instance, let us take heptane. So this is the expanded structural formula of heptane. So as we can see, the 7 carbon atoms are bonded to 16 hydrogen atoms. So that is the expanded. Next is the condensed formula. So condensed structural formula, each carbon with its attached hydrogen atoms is written as a group. So let us take again the expanded structural formula of the heptane. So in writing the condensed structural formula, it is best to start from left to right. So from left, we have one carbon atom which is bonded to 3 hydrogen atoms. So that is CH3. Then, followed by a carbon atom is bonded to 2 hydrogen atoms. That is CH2. Followed by another CH2 and another CH2 and another and another. And lastly, the carbon atom is bonded to 3 hydrogen atoms. All in all, we have the condensed formula of heptane, CH3, CH2, 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 CH3. And lastly is the skeletal. So, a simplified structure known as the skeletal formula or the line angle formula indicates the carbon skeleton in which the carbon atoms are represented as the ends and corners of the zigzag line. Let us consider this example, that is the heptane. So we have 7 carbon atoms which is bonded to 16 hydrogen atoms. So its skeletal is this zigzag. So the hydrogen atoms are not shown in the formula. Each carbon atom is understood to form bonds with the 4 other atoms, and each line in the zigzag represents a single bond joining 2 carbon atoms. So each terminal carbon is bonded to 3 hydrogen atoms, while each internal carbon is bonded to 2 hydrogen atoms and to 2 other carbon atoms. So the zigzag line is the skeletal formula of the heptane. So those are some concepts on organic chemistry. Thank you for watching, and I hope you have learned something.